So power we had discussed that frequency of the power is 2f. Okay. Section. Okay. So up to power we did na discuss na. Today we have to discuss the inductor. Okay. Inductor in frequency domain means like. Okay. Guys, these topics are very important. Okay. So write the next heading, that is inductor. Resistor, we understood that resistor is an element which will neither lack nor lead. In resistor, voltage and current will always remain in the same phase. Is this part is clear for everyone? Right? In a resistor, the voltage and the current will always be in the same phase. Is this part is clear for everyone? Okay. So today we are discussing inductor. Okay. So basically, particularly in inductor, this is your inductor. Okay. This is okay. I of t, I of t current is passing through. Right. Okay. So it's developing some positive negative v of t. Okay. Right. So if I of t is, I am assuming Im cos omega t, then v of t will be L di of t by dt, right? V of t will be L di of t by dt. So make it in a sign so it will be clear. I am sine omega t. Okay. So in a previous classes, if we discussed that about I of t is equals to Im sine omega t, and we if you will put this value, you will get omega L sine omega t. Im will also come, some Im will also come, omega L sine omega t plus 90 degree. That is sine omega t differentiation. If you will do it, you will get cos omega t, and omega will come outside. This cos omega t can be written as sine omega t plus 90 degree. Okay, so v of t is Im into omega L into sine omega t. We can write 1 at an angle 90 degree. Okay. So Vm, this Im sine omega t, v of t divided by Im sine omega t is equals to omega L at an angle 90 degree. That is, it means J part. Right. It means J part. And this v of t, Im sine omega t is nothing but v of t divided by I of t. You are getting something J omega L. Right. So what is the particular meaning of this? Your curve v of t is suppose your I of t you are getting Im sine omega t, and v of t, what you are getting v of t, what you are getting v of t, v is equals to L di by dt. So you are getting Im omega L sine omega t plus 90 degree. This can be written as Im into omega L. You can write it as a Vm. So v of t is particularly Vm sine omega t plus 90 degree, and I of t is nothing but Im sine omega t. Okay, so what I am telling, if you will draw the curve, if you will draw the sinusoidal wave, let me write. So if you are taking a sinusoidal wave, so if you are drawing your I of t signal, I of t is in the form of a sine wave only. So how the figure will be? I of t is equals to Im sine omega t. This you are assuming this particular, you are assuming as a omega t function. This is your I of t function. So how the graph will look like, means how the graph will look like sine omega t. Okay, so this figure is representing sine omega t. Okay, so this is your, this particular value, with this particular value is Im value. Now if you will draw the v of t curve, v of t curve, so v of t is what, 90 degree, 90 degree leading. So it will start from here. Okay, it will start from here. So it will go like this. Okay, okay, but wait, this will not be in the same, means this Vm value is greater than Im value, because it is multiplied with omega L is multiplied with Im, it is giving you Vm value, and we are assuming that omega L is greater than 1. Okay, so that means your curve will, so it will start from here only, but it will have some greater peak. Okay, suppose I am drawing like this, it having some greater peak. Okay, so it is going like, means wait, so okay, wait, just wait, means the curve is not going properly. So it's having some greater peak. Okay, it's having some greater peak. So just assume, means it's having some greater peak. Okay, that's why, means this is your this particular is your Im value, and this particular is your Vm value. It is starting 90 degree ahead. Okay, 90 degree ahead. So it will finish the curve. I'm just taking like this. So it will curve, the curve is sinusoidal curve only. Okay, it is not a triangular curve. So I'm not able to drop up properly in this. So you just assume this is your sinusoidal curve. Okay, it is going like this. Okay, so but if you'll draw the phasor diagram, if you'll draw the phasor diagram, okay, suppose you are drawing a particular phasor diagram. Yeah, why it's not coming? Oh, yeah, okay. So if you are drawing some particular phasor diagram, so these value you are taking these as a reference value. So can anyone tell me what is the angle of current? I of t is I of t is I of t is how much? I of t is how much, Prasanna? I of t is Im sine omega t, means it's having a 0 degree with a reference
1 at an angle of 0.
1 at an angle 0. So this belongs, I'm assuming the length of Im is particular this Im. Okay, this is the length of Im, and this is 0 degree. So your Im will be in phase with reference, right? Because reference is 0 only. So your Im is also coming as a 0 degree. Omega t is nothing. Omega t is not added with any angle. So that's why it will be in 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 reference, right, Prasanna? It will be in
Yes, in phase with the reference.
yeah, it will be in phase only, in reference only, phase with the reference only. So I of t is coming as a Im sine omega t, this particular. Can anyone tell me what will be the value of a v of t? V of t is Vm sine omega t plus
Omega t plus
90 degree.
90 degree.
So with reference what it's leading now, right?
Leading at 90 degrees.
Leading at 90 degrees. So it will be upside or downside? It will be clockwise or clockwise or anti-clockwise with reference. For leading we have to assume anti-clockwise.
Anti-clockwise.
Yes, for leading we have to assume anti-clockwise, correct only. So this is your, this particular value I am taking as a Vm sine omega t plus 90 degree, means this Vm is 90 degree. Vm, your voltage is 90 degree ahead, right? Your voltage is 90 degree ahead, means what we can say, for an inductor, V leads current by 90 degree. In an opposite way we can say I of t is behind V. In an opposite way we can say I lags V by 90 degree. This part is clear? Prasanna, it's clear? Vaishnavi, it's clear? Priyanka, it's clear?
Yeah.
Or you are facing any doubt? If you are facing any doubt, you can ask. This leading lagging concept is very much important. Corridor, it's clear for you? Okay. Okay, guys, you understood this one? And we can also make it like this. See, we can also draw like this. This is your V voltage, and if you are assuming V voltage here, so it should lead 90 degree. So we can take current in this. So current is lagging by 90 degree. So this is also true, and this is also true. Okay, this is also true, this is also true. We just we just wholly we move this part. So these both are true representations. Here also, if you will see, your voltage is in a anti-clockwise. From reference, you have to see from reference. So voltage is in a anti-clockwise, so that's why it is leading. If you will see from means, if you are assuming reference this, your voltage is again in a anti-clockwise, so that's why it is leading. If you will see from this point, your current is coming clockwise. Current is coming clockwise from, if you are assuming reference this. So current is coming clockwise, that's why it is lagging.
Lagging.
Yeah. So this lagging leading concept is clear.
Yeah.
Okay. Now, if you understood this one, na, like in a register, what we have seen, the net power will always be positive, right now? Right? You remember yesterday
Yeah.
class? We have V of t, we have I of t, and power is the product of V of t into I of t. So that's why we were getting positive only. The power will be always be positive only.
Negative will also
Yeah,
be the positive.
yeah, negative will be zero. So we will get a positive power only. So that's why means in a register we are getting, because negative positive is coming, positive is coming, negative positive is coming. So all the power was coming as a positive only. But if you will see for a inductor, the case will be different. How so? Here the lagging concept is coming. Suppose you have t. This is your, I am drawing V of t and I of t both in this, and your I of t V was leading by 90 degree. So suppose your I of t is this. I'm keeping this. Okay. Suppose your I of t, this is your I of t curve. This is your 90 degree. This 90 degree, this 90 degree, this. So your V of t is leading 90 degree. So V of t start with behind, means it start from here. It's leading I of t by 90 degree. Okay. It will start from here and it will go from here. But the phasor will be like this. Okay. So again, it will start from here. Yes. The phasor is coming like this. Right. Okay. It is going upward side. It is going downward side. So this is your V of t. Right now, this is your V of t. Prasanna, this part is clear?
Yeah.
Yeah. What will be the power? If you draw the power curve in this, how the power will come? This part and this part is, this is positive, this is positive. Okay. This is positive, this is positive. This is 0. So if this is multiplied with this, power is v of v into I. So if this particular is multiplied with 0, so it will start from here. Right? It will start from here, it will go like this, go like this, go like this, and it will come like this because it's coming as 0. 0 point is coming, 0 crossover is coming. So 0 is multiplied with this point. So the power will be positive up to this cycle only. Okay. Now this is positive, this is negative. So how the power will be
Negative.
negative. Power will be negative. Right. Now this is negative, this is positive, this is negative also, this is negative also. So power will be
Positive.
positive. Okay. Now positive, negative. Again power will be negative.
Negative.
Okay. Now this is positive, then power will be positive only. Positive, negative, positive, negative. Then again power will be negative. So what you are saying? Power is coming as a positive, negative, positive, negative, positive, negative, positive. Right? Everyone? This part is clear. Prasanna, it's clear? Prasanna, it's clear? Vaishnavi, it's clear?
Yes, sir.
Corridor, it's clear? Priyanka, it's clear? Okay.
Yes, sir.
Okay, guys. So, can anyone tell me what will be the average power? Average power, yesterday we have calculated. So, average power formula is P of t is overall 1 by time period,
One
0 to time
T
period into
0
V
T
of t into I
V
of
of T
t.
I of T.
Right. This is the formula for average power.
Average power.
Yeah. So into dt. To dt. So for inductor, 1 by time period we are taking, 0 to t we are taking. What is V of t? V of t is Vm sine omega t plus 90 degree.
And omega T plus.
Okay. So if you are taking sine omega t plus 90 degree, let me write it down. Sine omega t plus 90 degree. And what was I of t? I am sine
Sine omega T.
omega t into dt. So for this conversion, we can write 0 to t Vm Im sine omega t plus 90 degree. I am writing cos omega t. Okay, because the value is same only. And sine omega t into dt. I am multiplying 2 upside and I am multiplying 2 downside. So what you will get, Vm Im by 2t integration of 0 to t, you know na, 2 sine a 2 sine a cos sine a cos b formula, you know, 2 sine a cos a is equals to what? Sine 2a. Right? You guys remember this formula or forget? Sine 2 theta is equals to cos 2 cos theta into sine theta. Prasanna, you remember or you forget this formula?
I remember.
You remember, okay. If you don't remember, I think everyone remember this formula. Sine a plus b. Sine a
Cos A
sine a cos b plus cos a
plus cos A sine.
sine b. If you remember this formula, then substitute b as a only. Sine 2a will be sine a cos a plus cos a sine a. It will be 2 sine a cos a. So from this, it's this formula came. So that's why we have divided two downside and multiplied denominator and numerator by 2. So you will get the formula of sine 2 omega t into dt, right? So p of t is equals to vm into im by 2t 0 to t sine 2 omega t into dt. Integrations of sine 2 omega t will be, if the time period is 0 to t, you are having a, now the frequency is double. So earlier the sine curve was like this. Okay. Frequency double means time period reduced. F is equals to 1 by t na. So if frequency is getting increased, your time period will get decrease. So earlier it's covering this particular curve in this time period from here to here. Now this curve will generated in this period only, like this. Means the curve will generate in this time period only. If the frequency is increase, the time period will get decrease. So that's why earlier it was taking a t time period. Now it will take t by 2 time period. So anyways, you are getting the curve of a sine wave only, right? So integrations of a sine curve means 0 to t, 0 to t. So this is your, this particular is, you are assuming as a t only. It's positive, negative. This up to this part it will be your t, because the time period is decreased. So that's why number of curve is getting increased in this particular part. So what I am telling, always remember the average integrations of any trigonometric function, sine, cosine. I'm talking about sine function, cosec function, sec function. Average time period of a sine function, cosec function,
Zero.
0. So this is 0. So what you are getting, power 0. So the average power of inductor will always be 0. Is this point is clear? Is this point is clear for everyone? See what I am telling. Remember this. This is very important. See, you according to the question, you have a sine graph like this. Sine omega t graph I am taking. This is t. This is some particular v of t I am taking. Okay. So it was like this. So this is the total time period for this. Okay, but in a power, what we got? In a power, we got sine 2 omega t. Okay, sine 2 omega t. Here frequency, here 2 pi f1. Okay, you are taking. So here 2 pi f1. Now what it's happening, you are getting 2 pi into 2f1. So your frequency here is f1 which is nothing but F1 is equals to 1 by T1. Now your frequency is 2F1. If you will take, and F1 is how much? This particular 2F1 frequency, it is getting double. If this particular frequency is getting double, 1 by 2 F1, so this, the new time period, your T2 will become as 1 by 2 F1. So T1 was earlier 1 by F1. Now T2 you are getting 1 by 2 F1. Means earlier, suppose time period was time period was 4. This 1 by F1 was 4. Now your T2 will become half. Right? Your time period will become half. So that's why one in a one time period one sinusoidal is happening for a v of t curve. But if you'll come for a power, it will be twice. This is becoming your time period for power. Okay, that's why we are getting number of cases 1, 2, 3, 4, 4 pulse, because time period decreased by 2. Prasanna, it's clear?
Yeah.
Okay. Vaishnavi, it's clear for you?
Yes, sir.
Okay. So write down important point. In the positive half cycle of the power, inductor takes the energy from positive source, and in the negative half cycle of the power, inductor delivers positive energy to the source. So what it means? First, inductor is absorbing energy. From where it is absorbing energy? From source, in a positive half cycle. And in the negative half cycle, what it's doing, it's delivering energy. Where it's delivering energy? It's just delivering energy to the source, we can write. Okay, so this was the concept of inductor. So I hope everyone it's clear. Now come for the concept of capacitor. So suppose so this particular, oh, what I am doing, Wait for it. Okay. This is your capacitor circuit. Okay. Now you have a V of t. This is positive. This is I of t. So, what is the basic formula of a capacitor? V of t is equals to, or I of t is equals to C dV of upon dt, right? So if we are taking I of t is equals to Im cos, or let me write, if we are taking V of t is equals to Vm sin omega t, then your I of t was coming as a what? I of t, if you will derive this, then you will get C omega sin omega t plus 90 degree. Okay, this is cos omega t only, so that's why I have written in this form. So V of t is Vm sin omega t, and I of t is this C omega. Okay, so yeah, Vm will also come because it's a derivation. So Vm C omega, what I am telling you are derivating this Vm sin omega t, so you will get Vm omega cos omega t. So I am just
Getting the cos omega t in terms of sine.
yeah, in terms of a sin omega t. So Vm C omega into sin omega t plus 90 degree. This particular things I am taking as a Im. Okay, and this sin omega t plus 90 degree. So if you will come in a reference point, this is, why it's not coming, this particular is my reference means 0 0. I'm taking this as a 0 angle, 0 degree, that is your reference. So what is the angle of V of t? Voltage angle will be
Zero.
0 only. This particular will be in the same reference,
With respect to the reference.
with respect to the reference. Okay, this is your V of t, Vm sin omega t.
Sir, how you written VMC omega as IM?
Vm's, what you are having doubt?
VMC omega in terms of IM.
Yeah, that's a very common thing, yaar. I of t is what? C dV by dt, na?
By dt. Yeah.
So C, and what is your voltage? Vm sin omega t
Omega t.
d divided by dt. So if you will differentiate it, what you will get?
Okay.
C omega into
Omega.
Vm into cos omega t.
Omega t.
So that's why we got these things.
Yeah,
Okay,
okay.
and I have assumed Vm C omega as a Im. Okay, so can anyone tell me what will be the I of t curve?
Will be leading by 90 degrees with respect to the reference.
Yeah, it is leading 90 degree. Okay. So this is your curve for I of t, which is leading by 90 degree, because if you will see the reference, we are moving towards anti-clockwise.
Anti-clockwise.
So anti-clockwise means leading. This particular is leading. If anyone will ask about what is V of t, so if you will see from this point of time, is your V of t. If anyone will ask about V of t, so V of t will lag 90 degree.
Lag by 90. Lag current
Yeah.
by 90 degrees.
Yes, great. So what we are having a point here, in a capacitor, in a capacitor current, currents lead
Will lead 9 I by
voltage
90 degrees.
voltage
Sorry, will
by 90 degree, and we can also say voltage
lag.
lags current by 90 degree. I hope this part is clear for you guys.
Yeah.
Okay, so if this is clear, mm, now same thing we have to do for power. Okay, so suppose if you are drawing the, so current means what was the equation of a current? I of t is Im sine omega t plus 90 degree. What was v of t? Vm sine omega t. So this is your v of t curve and I of t. I'm plotting both in the same. This is time period. So what is the curve of v of t? V of t will start from like this. You are getting like this, right? It's going like this. So I'm just drawing from here. So this particular point is your 90 degree. This you are taking as a time period, capital T. This belongs to your v of t curve. V of t is equals to Vm sine omega t. Now about I of t, it is leading by 90 degrees. So that's it will start from here. And I am assuming that Im value is greater than Vm. I am just assuming. It may be lesser also. It's not true because Vm into C omega is your Im. So I am assuming this Vm, this C omega value is greater than 1. So that's why I am assuming Im value is greater than 1. It may be less also. So I am assuming it has a greater than 1. So from here to here we are having okay, and from here to here we are having, so and from here to here we are having, from here to here this particular, okay. So this is your 90 degree. So it's a leading the curve by 90 degree, right? Leading the curve by 90 degree. So what will be the power in this particular curve? What will be the power? Suppose we are multiplying. Power is what? Power is, so power is what? V of t into I of t. Power is V of t into I of t. This is positive, this is positive. This is the maximum value, this is 0 value. So this multiplied by this, so it will start from 0. I'm sorry. And this is your maximum value and this is your minimum value here. So again it's coming as a 0. This at this point. So it's going like this Okay, now you have negative, you have, see, so this is positive, this is negative, so it will come negative. This is negative, negative, so it will be positive. Right, Prasanna? Yeah. Okay. Vaishnavi, you are getting this thing now? And this is your negative, negative, it's positive. This is positive, this is negative, so it again it will come negative. This is positive, this is positive, so again it will come positive. So you are getting a sinusoidal curve, right? So see, means what I want to say you, see, in a half cycle only you had covered this particular one full cycle power, one full power cycle, it's covered. That means your frequency is getting double to in this also. So frequency means power frequency is getting doubled only. In register also we have seen that power frequency is getting doubled. In every cases the power frequency will get doubled only. So if you will calculate like this, P of t is equals to, P average power is equals to 1 upon t, 0 to time period, V of t into I of t into dt. 1 by t, 0 to t, V of t is Vm sine omega t, and I of t is Im sine omega t plus 90 degree into dt. So I can take it as 1 by t, 0 to t, Vm into Im sine omega t. This can be written as a cos omega t. This I am multiplying 2. Okay, so Vm Im by 2t, we are getting 0 to t, 2 sine omega t into cos omega t is sine 2 t into dt. So this value is 0. So P power, P of t is coming as what? 0 only. So for capacitor also the average power will be 0. Everyone, it's clear? If anyone is having a doubt, they can ask. Prasanna, Vaishnavi, Corridor, Guna, Priyanka, is the thing is clear up to here?
Yes, sir.
Okay. So this was the story of a capacitor, and we discussed the story of an inductor also. Now we'll move to the further topic, that is series RL. When the combinations of a R and L both will be there, then what will happen? Okay, when the combinations of R and L will be there, then what will happen? So write down the series RL circuit. Series RL circuit. Okay. So see, This is R, this particular is L. Okay, now guys, if you have some voltage like or if you have some current, means I'm just taking in example from current. Right. I of t I am taking, I am sine omega t. Okay, and v of t will be, apply the KVL. V of t will be I of t into, this is inductor, not impedance, not reactance, so you have to convert, and we already know the inductor can be converted in the form of XL by j omega L. Okay, so R plus j omega L is coming. Okay, so V of t is nothing but, or if you want to, if you also means like we also can get it as like this, I of t into R plus j omega L into I of t, or if you want in the form of like this, positive negative, positive negative, this is your VR, this is your VL. So value of a VL will be, value of a VL will be I of t, same current is flowing, I of t into L di by, wait, V is equals to L di by dt na. So V of L is equals to L di of t by dt. So you are getting the value of V of L is equals to L di by dt. And from this, after solving, we know that VL by I of t, we are getting one term, that is j omega L. That is your reactance part of this particular point. And this particular V of R will be nothing but I of t into R. Okay, this part is clear. Okay, now suppose we have some reference point. Draw. Now suppose we have a reference point. This is your reference point. Reference. So if you want to draw the VR voltage, so VR voltage, what it is coming, I of t into R, right now, and that is I of t is Im into R into sine omega t, that is your voltage across V of R. So same, and this is your reference, means a 0-degree angle is coming. So what I am telling, this is your VR voltage, and this is your VL voltage. VL voltage, what we are getting, the VL voltage L di by dt. So if you will solve this, you will get V of L is equals to Vm sine omega t plus 90 degree. From the previous concept, 90 degree it will lead. So this was your V of L. And if you want to know the V of t is what? This V of R plus V of L. So V of R plus V of L, V of R means V of R is getting added to V of L. So you have to take, means like this. this v of from adding v of r to v of l, that's why we are taking v of r to v of l. And this belongs to what? It belongs to voltage v of t. So this is your phasor diagram. And what about your current I of t? I of t will be in the same phase only. This. So I of t and voltage of resistor will be in the same phase, neither lead nor lag, because we already know the voltage of resistance and the voltage of inductor will neither lead nor lag. Okay, voltage of this particular voltage, I am talking about v of r, I am not talking about v of t, right? So you are getting what? You are getting v of t is equals to I of t into that r plus j omega l, j omega l. So I of t into r, you have one term, and you have one term I of t into omega l, I am writing as a 90 degree. Okay, so this is the story of that r plus l inductor. Okay, now we call one term that r plus j omega l is known as capital Z impedance, r plus j omega l. This can also be represented in the form of a triangle. This is the vector additions. So r is with angle 0 degree and omega l is with 90 degree. Take the reference, draw your r with the reference because it is 0 degree. What about omega l? Omega l will lead this reference by 90 degree. This is your omega l. We call it as a xl. And what is Z? What is Z? Z is nothing but that r is getting added with omega l. Okay, so this is your Z. Z is r plus j omega l. So this is the vector addition. So if you want to calculate the value of z, you need to do root under r square plus omega l square. It will have some angle tan inverse omega l by r. Okay, tan inverse omega l by r. So this is your angle. So means what I am telling, suppose you are writing r here and you are writing xl here. Xl is omega l. So this particular is your z. The angle theta is this, because tan inverse p by b, angle will give p by b. So perpendicular is this and base is this. So tan inverse omega l by r, it is the angle of z. So this, and now you understood the concept. In a RL series, z is equals to r plus j omega l. In this, what we are getting? Inductor leads resistor by 90 degree, and resistor lags inductor by 90 degree. This part is clear, guys. This part is clear, guys. Prasanna, it's clear or it's not clear? Prasanna, I am asking.
Yeah, it's clear. Yeah, it's clear.
Okay. So, okay, fine. If it is clear, you know the things like you understood that this. Wait, why it's not coming? So you understood this means Z is equals to that Excel is leading and this leading and lagging concept. So one thing, and this is what about power? How the power will lead and lag? The concept of reactive power will come in this case. What is reactive power? Okay. So in a AC circuit we have a two different power. One is real power and another is reactive power. Okay, one is real power and another is reactive power, right? So make this diagram. This is VL, this is your VR. You are getting a theta is coming. This is XL, this is your R, and Z is coming. And this is your S, this is your theta, this is QL, this is P. So this particular thing is representing your reactive power and this is your real power. How so? I will tell you. Now you understood. If you have a circuit like this, suppose I am taking in a phasor form V at an angle some theta degree. Okay, this is R, this is j omega L. Now you understood the inductor can be represented as a j omega L. Now what is current? Current is V at an angle theta divided by R plus j omega L. This is your Z, and Z can be your impedance R plus j omega L. So if you want to write this in the phasor form only, so we have V at an angle theta. R plus j omega L can be written as R square plus omega square L square tan inverse omega L by R. So this I is V by mod Z. Why mod Z? Because Z is equals to R plus j omega L. So mod of Z value will be R square plus omega square L square root under. That's why I have written V by mod Z, and angle was theta, and this angle is going upside, so it's becoming minus tan inverse omega L by R. So I you are getting V by mod Z at an angle theta minus tan inverse omega L by R. Okay, so what is the difference between V and I? So suppose you have a particular reference, you have to draw V at an angle theta. So I am drawing, it is leading by angle theta. This is my V. What about I? I will have some angle. This will be omega L by R, tan inverse omega L by R, because we are getting the angle theta minus tan inverse omega L by R. So if this angle is theta, so I am taking this particular angle is omega L by R. I am taking this particular angle theta minus omega L by R, right? So wait. So what I am saying that V is leading by angle theta to reference. Okay, and your I is having some angle theta minus tan inverse omega L by R. Theta minus tan inverse. So theta is from this particular reference to this particular voltage. Theta is from this particular reference to this particular voltage. So that means in a theta we are subtracting some value. So this particular value is theta minus tan inverse omega L by R. We are substituting. We are just subtracting some value, tan inverse omega L by R. So I is this. And what is the value of this then? If this is theta and this value is theta minus tan inverse omega L by R, so theta minus theta plus tan inverse omega L by R. So this get cancelled out. So you will get omega L by R tan inverse. So can anyone tell me, this is the story of that RL. So can anyone tell me what is the relation between V and I? So voltage leads current by what angle? Prasanna, voltage leads current by what angle? Voltage leads current by what angle? I am asking about V and I relations. Voltage we are understood that.
Tan inverse omega L by R.
What? Tan inverse omega L by R. Yeah, correct. So voltage leads current by an angle tan inverse omega L by R, and your current lags voltage by tan inverse omega L by R. This part is clear? So if you have R and L network, so your voltage and current relationship will be like this. So your voltage leads current by tan inverse omega L by R, and your currents lags voltage by tan inverse omega L by R. This part is clear? Prasanna, this part is clear?
Yeah.
Okay, this thing is clear, then it's fine. So what we are getting means like you understood that I is equals to V by Z and theta is equals to theta minus tan inverse omega L by R. So if you have V is equals to V at an angle theta, and if you have I is equals to V by Z, V mod z at an angle theta minus tan inverse omega L by R, theta minus tan inverse omega L by R. So what is your power? Here in AC we denote power as a S. What is your apparent power? S is equals to, means in apparent power both real power and reactive power will come. So V of theta into I of angle phi. So as what you will get, V into I at an angle theta plus phi. So if you will write the value, so what you are getting, V square upon mod z at an angle theta plus, that is, yeah, I we are getting minus tan inverse. Okay. So what you are getting here, V is at an angle theta and I is also at an angle theta minus tan inverse omega L. So this both will get added. So you are getting 2 theta minus tan inverse omega L by R. Right. 2 theta tan inverse omega L by R. And you know one thing, that S is also written as a mod V into mod I. This you will get the value of S. Okay. So by this way you can calculate the overall power, right? So you are getting the value of S is V square upon mod Z at an angle 2 theta minus tan inverse omega L by R. Okay. And these things if you will put in the A at an angle theta means you can write A into e power angle j theta. This is equivalent to this. So V square by mod Z, you can write cos 2 theta minus tan inverse omega L by R plus j sin 2 theta minus tan inverse omega L by R. So V square by mod Z into cos 2 theta minus tan inverse omega L by R plus j into V square by mod Z into sin 2 theta minus tan inverse omega L by R. This particular is known as real power, and this particular is known as your reactive power. This is denoted as a P, and this can be denoted as a Q. So S is the combinations of P plus JQ. S is the combinations of P plus JQ. I think yeah, everything is correct only. Means if you are assuming, see, if V is equals to V at an angle theta, we are assuming V at an angle V divided by mod means I is nothing but V by mod Z, and V is at an angle theta, and mod Z, your mod Z value yeah, so yeah, I is equals to V by mod Z and theta, and I value was theta minus tan inverse theta minus, okay, let me correct it one thing. No, it is correct only. Yeah, this is correct only. V at an angle theta and divided by r square plus omega square plus l square, we are getting tan inverse omega l by r. So this is your v by mod z, and this we are getting as a theta. This, if you will shift it into the upper side, it will become minus tan inverse omega l by r. And I, we are getting v by mod z theta minus tan inverse omega l by r. So that's the same thing I have written, v divided by mod z at an angle theta minus tan inverse omega l by r. If you will calculate the power is what? Power is nothing. Power is just the multiplications of v into I. Power is just the multiplications of v into I. So if you will multiply this v at an angle theta into I, and you are having a v at an angle theta, and you are having a I, particularly v divided by mod z at an angle theta minus tan inverse omega l by r. So these two will get added. So this angle will get added. So I am assuming this particular angle as a phi. So that's why I have written theta plus phi. Now if you will do the calculation, so theta will become 2 theta minus tan inverse omega l by r will be there. Okay, so v square by mod z 2 theta minus tan inverse omega l by r. So one thing is, means 1 at an angle theta can be written as e power j theta. Okay, e power j theta. How? 1 at an angle theta means e power j theta. This is the convention. So means that is v square by z, means we can represent this in the form of complex form. So whole angle will be multiplied with come under the cos terms, and whole this angle will multiply comes under this particular term, and you are getting what? You are getting this particular value. V square by z cos 2 theta minus tan inverse omega l by r is your real power, and j v square by mod z sin 2 theta minus tan inverse omega l by r is your reactive power. Prasanna, is this clear, or still facing any doubt?
Yeah, please.
It's clear how the value came, and we are representing s is equals to p plus jq. Okay, so we can also write now your s value can be written as s is equals to tan inverse s is equals to root under p square plus q square at an angle tan inverse q by p. So s is nothing but mod of s at an angle tan inverse q upon p. So how can we represent this form? Your real power, we are taking it is in the reference. So real power is having a 0 degree angle. So it will be P only. But what about Q? For RL series, your reactive power is having J, that is
90 degrees.
90 degree. So it will lead. The Q will lead. So Q is leading by 90 degree. And this P plus Q will give you S. Right? P plus means from P to Q it's added. So that's why I am getting like this. So this is your S. Right? This is your real power. This is your reactive power. Is this clear?
Yeah.
Okay. So if you are assuming, means like suppose this is your theta. Okay. So what is the value of a theta we are getting? Cos theta. Cos theta is b by h. Base by hypotenuse. So this is your base.
Real.
What you will get?
Real base.
Base by hypotenuse. So base by hypotenuse means we will get P by S. You are saying, yeah, P by S will come. And we have here also, yeah, or let me draw the circle. So there was, we are getting R here, XL here, this particular was Z, and this was theta. So cos theta is can also be written as R by Z, base by hypotenuse, right? We have VL here, this is your VR, this is your net voltage, and this is your theta. Cos theta can also be written as VR by VL, right? Right? All are true. Cos theta can be written as P by S, cos theta can be written as VR by VL, cos theta can be written as R by Z also. Okay, what about tan theta? Tan theta will be P by B, perpendicular means Q by P. Here if you want to write, tan theta is equals to R by XL will come, and here what will come? Tan theta is equals to VL by VR will come, right? Suppose means what I am telling, tan theta is VL by VR. This is your magnitude value. So what is VL? VL is I into omega L. And what is VR? I into R. So you are getting cancelled out. So that's why we are getting omega L by R. That is your XL by R. See. This will be XL. Sorry. P by B na. So same result we are getting. This tan theta is equals to XL by R. XL by R. Right? Tan theta is coming as a, this XL is getting divided by, XL is divided by R. So tan theta is XL by R. Cos theta is R by Z. So this is the concept of, means like you have to do the calculations like this. Don't need to remember anything in this. You just need to revise this topic, and means you have to practice by yourself. If you will practice these things by yourself, then only you will be able to do this in exam. And this particular is angle theta. It may be zero angle also. Okay. So I didn't I just did it by myself only. How it is possible? Because this is nothing. This is some simple multiplications. How to do the polar conversions and all. If you know that things, this is just a game, and you should know, means like what is reference value, what is lagging and leading concept. So that's why I told you the first class is very important for lagging leading concept. You know, there is a term known as a power factor. Right. Now the things what you need to know, write it down. Cos theta is equals to VR by V. That is lagging if inductor is there. We had seen. Cos theta can also be written as R by Z. R by Z. Lagging. Cos theta can also be written as P by S. It is lagging. What is power factor? power factor is active power upon apparent power. Apparent power means total power. Apparent power. Active power, meaning of active power is your P and apparent power is your S. All are in the mod form. So cos theta. We had seen cos theta P by S. So this is your active power, this is your apparent power. So write it down. Power factor angle indicates the position, current, phasor with respect to the voltage phasor. Okay. While defining the power factor, for any circuit, voltage phasor is taken as the reference. Voltage phasor is taken as the reference phasor. Okay, because in real time system all the loads are connected in parallel. Because in real time system all the loads are connected in parallel. Okay. So write it down. What is the benefit of a power factor? Means like a power factor. Wait, just wait. Power factor tells how much of the apparent power is utilized. Okay, how much is the apparent power is utilized? If the power factor is high, then the active power delivered is also high. If the power factor is high, then active power delivered is also high. So what is power average? P average was, we know, the 1 by t 0 to t p of t into dt. So P average, if you will calculate, 1 upon t 0 to t v of t I of t into dt. So suppose you have 1 by t 0 to t, you have some angle Vm sine omega t plus theta degree, and you have some current Im sine omega t into dt. If you'll solve this, you will get Vm into Im by 2t, 0 to t, and this is sine omega t plus theta into sine omega t into dt. We had multiplied 2 here, so that's why 2 is came. And this is in the form of sine A, 2 is there, 2 sine A, sine B. So what is the formula of a 2 sine A sine B? Vm Im by 2t, this is t, 0 to t. So sine omega t plus theta minus omega t. So this is nothing but sine A minus B. Oh sorry, cos will come. Cos A minus B minus cos A plus B. This is the formula of a 2 sine A sine B, cos A minus B minus cos A plus B. So what you will get? You will get cos theta minus cos 2 omega t plus theta into dt. Okay. So if you'll solve means you will get this is the constant term. This cos theta is a constant term. So you are getting the result as, and if you will Vm into Im by 2t, you are doing a cos theta into dt, 0 to t minus 0 to t cos 2 omega t plus theta into dt. So this is the trigonometric function. So it will be 0, average value is 0, but it's a constant value. The theta, it's a theta, not omega t. So you will get Vm Im by 2t into cos theta, and it will be t. So this will get cancelled out. So P average you are getting as a Vm into Im by 2 to cos theta. So what is the P average? P average is Vm Im by root 2. This 2 can be written as in the root 2 into root 2. This is your cos theta. Vm by root 2 is Vrms and Im by root 2 is Irms cos theta. This is your average. Okay. So if this value is high, means your average power is also high. If this value is low, your average power is low. So that's why we need to improve the power factor. How can we improve the power factor? If you have this cos theta value, we know that R upon Z, right? Prasanna, right now we have cos theta is the angle curve. You have to see the angle curve, means like again and again. This is your R, this is your XL, this is your Z, this belong to theta. So cos theta is B by H. B base is this and hypotenuse is this. So R upon Z. So how can you improve the cos theta? If you have the combination, this is your XL and this is your R. This is R by Z. How can you improve the angle of cos theta? By increasing the value of R by Z ratio. If your R by Z ratio, if you keep means increase, then your cos theta will become increase, and the cos theta value will be lie between -1 to 1, -1 and this 0. If the value is between -1 to 0 and this is from 0 to 1, so if -1 to 0, this is known as a lagging, and if it is between 0 to 1, this is known as a leading power factor. If it is between 0 to 1, it is known as a leading power factor. If it is between -1 to 0 or 0 to -1, it is known as lagging power factor. So it depends, because we are in inductor, we are solving in inductor, and inductor we know that current lags by 90 degree. So power factor will, for inductor case, the power factor will be lagging, and the value will be between -1 to 0 to -1. But here the value you need to substitute, not -1 -0. You need to substitute the value like that, means like a point 0.5, point 0.2, whatever the value is coming. And you need to say that for RL series the power factor will be lagging. Right. Up to this is clear, Prasanna?
Yeah.
Or any doubt? If you are facing any doubt, you can ask. You understood this part?
Yeah, got it.
Got it. So this is a very important topic, very very much important topic. Now we will go for, means like we have one important topic left, that is RL we did na. Now we will go for the same thing. Will repeat for RC also. So if you are not getting the things, it's okay. We'll repeat the concept, this concept 3 times for RC, for RLC, so that you will be able to understand. The concept will be very crystal clear. So, but you need to keep on revise these things again and again, again and again, right? And you have to practice by yourself. Okay, Prasanna. So this is the combination of R and L. When we'll study the combination of R and C, then you will get to know this thing, right? And in a parallel RL circuit and in a parallel RC circuit, we'll repeat this concept again and again, 4 or 5 times. Then you will not have any difficulties in this concept, because for me now, when I was studying this concept, it took me a lots of time to understand. So that this concept is means while I am teaching this concept, I am repeating again and again for RL, for RC, for RLC, so that you guys will not face any problem. Okay. So we completed like up to 50% we had covered our topic. 50% done, the network syllabus. Now the 50% is left. Okay. So I'm ending up the meeting. Today's meeting is over.